Thank you, everybody, for having me here. I'm glad. Since I know only a fraction of the English words, I will probably speed up, and we can use that. Well, we have done a simple research. See how this works. Next one. On bats. Well, it figures bats are night active. They have eyes, especially for their appearance in the night. More rods than cones if you compare them to us, and they see color a bit not so good as we do, and they have a very different frequency sensitivity. Oh my. Yeah, I know I'm getting it. Well, we've seen that. Light is a growing problem. We also have a lot of observations of bats being hindered by light. We have anecdotal and real studies of fly paths that have been abandoned when they were lit, or at least they moved to a darker path. Not always a more preferable path for that. They delay emergence if you light them. In extreme cases, roosts are abandoned. But we also know that there are bats which regularly hunt near street lights because street lights attract insects. But even there, if you look at them a bit closely, you see that they spend most of the time outside the light cone. They just dive through trying to get the food, but they're not in the light cone all the time. So, well, it's logical. Bats are night active. They try to avoid light. It's something they learn to do so in the course of their evolution to being bats, and most probably they do this to avoid predation and to get to these insects who try to avoid predation. But light is also constantly disturbing their adaptation to low light levels. If you're walking outside in a dark forest and you make a note, I've seen this bat here, or a badger, or whatever, you put on the light, suddenly you are not on scotopic vision anymore, but this takes a few minutes. And possibly, I am outside in the night a lot, and I'm very disturbed by light. I don't like flashlights. Could it be the case that bats are also very irritated by light? That's something that's difficult to ask them, but anyway. There's all kinds of things which advisors, consultants already do in projects. We clearly ask ourselves the question, do we need light, yes or no? Where do we need this? Where can we do without? But if we do need lights, how do we direct the light? How do we organize that it's not dispersed everywhere? How do we work with reflection? When do we light? Part night lighting. I learned this English phrase now. And at what intensities? Can we work with on-off periods in season and nights? All kinds of things we are already trying to do. But what we also do is blocking lights. LED lights are much more directed, so that's interesting. We've done simple things as, like seen here, just making one part of the light in a part black, and then you get more hunting long-eared bats on the darker side, things like that. We are also using planting bushes, trees, etc., in order to protect certain habitats, like you can see above now. But what we didn't use was working with colorless light. So we asked ourselves the question, would there be a color spectrum that is okay for human needs, safety, and would be not or less disturbing for bats? So what we did is try to find information on spectral sensitivity in bats. Well, there is none on European bats. We find a few Corolla species where there is research. And if you look at the dark blue line, this is the bat species. If you look at, what is this purple line, you see our spectrum sensitivity. So what would happen if you would use a small spectrum like this, where, well, people are still relatively sensitive, but bats are much less sensitive. In the course of doing this, we came up with something we now call a human bat response ratio. Actually, using this, you can predict different light sources if you know the spectrum, how well they would fit the needs of the bats. We would, though, like to have spectral sensitivities for European bats. That's when somebody can do this research, please. We need physiologists to do that. And then we started testing that. One thing we also did is testing a green LED light, which is actually developed for bird problems around oil rigs, but now, because it was there, is effectively marketed as being nature friendly. It's turning up everywhere in the Netherlands, and I am not okay with that. This might be good for the birds, but if we are in a scene like this, maybe this site is more important to bats than birds, and we should not have chosen green. Okay, so what have we have been doing? We have been looking at this human bat response ratio, and then you see white light has a low ratio, and this small orange amber kind of color has a very high human bat response ratio. So this predicts that should be good for us and not for bats. Then we did a test. We needed a dark area, which is not so easy in the Netherlands. But in a forest there was a canal and there were no street lamps, and it was a flight path of pond bats. And that's also something which bat people might know, but others. Flight paths are really sensitive for light. So that could be a good testing area. What we did is we put bat detectors floating on the water in a very high-tech construction you see there, all available in your local building shop or something like that. Then we put up street lights in the forest. So our state forestry service were okay with that, and we got electricity from a nearby farmer. And then we had street lamps in a dark society, and we tried to fit that lighting half of the canal. And of course you have an expectation, so darkness should not influence the way the bats are going over the canal. I remember I forgot something. And we would expect, if this is a light area, that the bats would fly here and much less here. So this is the expectation. Dark and amber, if it works, would have no or little effect on the bats, and the other colors would have effect on the bats. We had a measuring scheme. It was too complicated, low budget research to alter the colors every time, so we worked with dark white, dark amber, dark well. And it looked like this before the sun went down completely. And then with amber it looked like this, and green like that. Well, you can see that. Then we had thought that the bats would nicely fly to the right or the left of these stereo detectors, but sometimes they were very close. So there are occasions where you can definitely see right signal is stronger, or here they are both equally strong, so the bat was too close to the detector to tell. And on the other side you could see it went by on the left side. And we had somebody process all these files who did not know what question was. So we tried to not have somebody thinking in the right direction. Well, since we did not have this alternating scheme, but the colors behind each other, we had to look at, well, is there a pattern there that could influence our data? Well, there is a lot of dynamics in how many bats are flying on this flight path, but it's not correlated to season, so for the moment we think, okay, you can analyze this set of data. And, well, the interesting thing is that if you look at what happens, how the bats use this, that, well, the bats are on both sides of the detectors in the dark, and they are on both sides of the detectors in the amber situation, but with white and green, they start to move to the right, away from the light. And this was significant. We've also looked at how many bats are passing at all in correlation to a certain color. And then you see that there are less bats passing when the set was lighted white or green. So a number of bats are trying to avoid our setup altogether. Being on the shore of this canal, we could also confirm this. At the time of planning this research, we did not think of having monitoring points there. But we were there with our own detectors, and we, well, in the dark, nobody on the side of the canal, and with light, suddenly they are, well, avoiding the light. So, conclusions. Working with this human bat ratio is okay. It's a good way to try and have an idea of what a color might do with bats or people. we conclude that amber is less disturbing than green and white, but we tested this flight path situation. Can't say what this does in a lot of other situations. Now we are trying to, what we would like to have more detailed tests of amber or an amber-like situation in other situations, near roost, in a hunting field, what have you got. And we would very, very much like to have wavelength response curves for European species. And then recalculate these human gas sensitivity ratios. There are sites where this is already being, no problem, where this is already being used. We got funded by our Ministry of Transport because they had an ecoduct, and on the other side of the ecoduct there was a road where especially young females went to go to a riding site. So this had to be lighted. We could not argue no lights there, it had to be lighted. So we came up with amber, and this is reacting on people and bicyclists going by and not reacting on cars. So it's dark when there is nobody there. If there's somebody on foot, the light goes on and the rest is dark. Okay, so now in the Netherlands we are trying to work with that, and what I encounter is maybe a consideration, and it was also mentioned in the talk before, that human acceptance in psychology is also very important. And we have sites where every rational argument you can make, it is absolutely okay to work with amber. And the law calls for us to do this, the bats need this, but still the public is against us because they think you can't see your enemy in the dark, or you can't recognize facial patterns, or so in getting this to work out there, we also have to work with getting this accepted. Okay,